Oh, okay, it's good. It's good.
Mine still says off air.
Mine says live.
So does mine.
Oh, okay. Oh, mine says it now. Okay.
Good.
Awkward first
Okay.
part. Okay, hello group. We are in week 3. And let's see. So this week we read discussions on the UDL principles in mathematics. So we kind of looked at modeling of math and also like differentiated instruction with math, and then what teachers can do to help with math instruction and what technologies can be used to help with math instruction. Um, let's see. The first one is like the first question that she wanted us to answer was what types of instructional practices were used in certain math lessons. So, did anyone have any like examples of that? Or I could share out mine first.
Yeah, to share off yours.
Okay, while I'm talking, I might as well. Sorry, I keep looking at myself, but I need to look at the camera.
All right.
Okay. So it talked about Miss Howard's 4th grade class. They were reviewing multiplication facts, and they already knew how to do 10 times 10, and then they needed to learn how to use products on 1-digit multiplications of 10. So like 1 times 10 is 10, 2 times 10 is 20, 3 times 10. So they already knew that. So this was like a reinforcing lesson. So like the types of instructional practices. First, the teacher listed the goal. So like, find products of 1-digit numbers and explain how to do so. And then it starts, she when we read about modeling, she starts with the modeling of it. There's like an assignment, and it says there are 6 grades and they need to give 14 computers to each grade. How do you arrange that? And so she created an array kind of, and she asked students questions about it. And then she gave them a handout after she modeled how to do it. And then she kind of went around and like asked them like what different strategies they all were using. And then so in a way, that's like how the lesson was like built. It was modeled, and then she went around and kind of like focused on like their progress.
Yeah, to build off that, like I like how she used the visual of the rectangle array, like of squares on the whiteboard. I think that helped, and like she gave the handouts to do with the partners. And like I said last week, I feel like with partners it helps a lot because you see a different explanation. And after they were done with the handout and stuff, she explained what the 6 rows were and why there were 14 in that row. And I think with the visual and like the auditory, it helps them learn better than just like listening to it.
With that one too, she did a really good job about like letting the groups go to different hands-on doing what they thought would work best, and then like she encouraged like certain groups she knew had like motor skill issues to go use a different resource. She did really well utilizing everything that she had in her classroom.
Right, because she brought in the base 10 blocks and the visual thing with the rectangle multiplication manipulative for the technology. So it was good that she used like a bunch of different things rather than just one.
Exactly.
Yeah, because that really helps. Like, she doesn't like just stick to one specific thing during her lesson because she knows that she has students that have different like learning styles. So she adapts to like what the students need, so they can learn and so they can like understand what they're learning in the class.
Mm-hmm.
And she kind of like I said, she did like a formative assessment at the end where she asked them like, what kind of strategies did you use? And then she wrote down all the different strategies. And then it's like, there are multiple ways of doing something. There never is just one way of doing something. And I think that's what UDL principles really encompass.
Yeah.
Mm-hmm.
Showing that there's multiple ways and like your way isn't wrong if you got the right answer.
So I think that's really good on the types of instructional practices that we all read in that. In terms of what type of technology was used to help direct that. So like, obviously you talked about base 10 blocks, like any kind of concrete manipulatives, really helpful in that situation.
Yeah, and I think she also, I don't know if it was this one or not, but using like ones on like on screens and not physical things, because like not all students need physical, but they just need like a visual representation of it and like move them on like the white like on the smart board or whatever, and that helps it like help them retain the information better that way.
Yeah, the interactive whiteboard was definitely used the most for sure throughout these lessons.
There was another one, the guy used like Google Docs where like the group work so that the kids could work together and edit and
Each other.
a document.
Yeah.
Yeah. Someone mentioned interactive whiteboard yet?
Yeah.
Yeah. Sorry. It's like an interactive whiteboard. It's called a rectangle multiplication virtual manipulative.
Yes.
It's like using the base 10 blocks, but it's like virtual, I guess. It's easier for students who can't physically, like she mentioned, James' fine motor skills, like were having some trouble, so she like suggested that he do that one because I think it was easier for him. So like I said, accommodating for those, like there's so much technology like to be used
Right.
help instruction, and there's just so many options. I feel like it's kind of makes me like nervous to be a teacher. I mean not nervous, but like there's so many things. Like how do you like encompass all of that? Like it's so.
Oh, definitely.
Yeah. So yeah, that's pretty much all technology. I mean, there's not too many. I mean, there's a lot, but in terms of that lesson, she only used a few, but yet it was so effective.
Yeah.
Now, as we mentioned, UDL principles, like what kinds were they used well? She, like I said before, actually in the past, she was able to model, and then she asked students questions about it, and then students that answered maybe not quite correctly or had some type of misconception, she was able to really address that right there and then and really like solve the problem before it gets bigger. I feel like they slip through the cracks.
Yeah, she like let the students answer and like review the questions first, and then like class discussion I think is really important because people can see like what everyone else thinks. And then like after the class discussion, she like pointed out what was right on the whiteboard, and I think that was a big part of it.
Yeah, and that just goes like to show like how other students think and like what they may feel or think is correct, and maybe they don't understand why it isn't correct. So having that like feedback from the class and asking like, oh, well, what do you think about so and so's response and how they got to that, and just to determine, okay, we have two different answers here. Which is the right one, or are they both correct, and why? And do you see how that works? Um,
Yeah, I definitely think that her engagement amongst the peers she was really good at utilizing that and encouraging them to work together when they were in those small groups.
Yeah, because I mean, it used to be where we never really discussed math.
Yeah.
Like it was
They
kind of
also.
like.
Oh, sorry. Go ahead. Finish.
I'm just saying, like, it used to be just 2 + 2 = 4, and that's it. It wasn't like, why don't you have a discussion about why 2 + 2?
yeah, you never question it. You just say, okay, that's what they say, so that's
yeah.
I guess what's right.
Yeah.
They also use like they mentioned like using individual whiteboards, and I think that's good because it's a place where they're still doing it on themselves, but it's easier to erase something that they think is wrong, and then like presenting it to the teacher to see like if they're right or not. I just feel like that's a really good way because when I use whiteboards in like elementary school and even high school, I felt like I was still learning something because I was interacting.
Because you were writing, like show it off, and then like if there's anything like that's like a misconception of the idea, they can just like fix it, really quick because it's a whiteboard. Like it's not so permanent.
Mm-hmm.
I like that one too a lot.
And then I already
also
what
that also like helps let the teacher know like to see what students may be like struggling more and which ones don't, if they have that time to reflect and then show their answer, and so she can go back to them later on if she has to like move on right then, if the majority of the class is picking it up and whatever, and she can just go back to the other kid and spend more time with them later on that.
I didn't even think about it as beneficial, like for the teacher. That was a really good point, because that is something that like can help a teacher visualize who is on and not on track, like that easy. You know, like yeah, some people get it wrong, but like that is a good pinpoint where she can see easily and fast, like, okay, you are struggling a little bit. That's who I need to look for in the next little group rather than this guy who I thought needed it.
Mm-hmm.
Yeah, I think, this lesson was really spot on with the UDL principles and uses of educational technology. I really think that we all hit those points that we needed to for this part of the discussion. So I think we can move on to our own individual researches on the different math topics, I think, or subjects, not subjects, but like, strategies.
Yeah, the
I
different
heard it last time. Does someone else want to start their strategy?
I'll start.
Okay.
So I did the organizing strategy, and I said a way students could use organizing as a strategy is by making it visual and allowing them to use like different colors like on a chart. I said that this could be helpful because after they like collect all their data or like their fractions or whatever they need to collect, they can easily see the differences in the data from like their visual, whereas like, oh, the pink is only taking up this much space, but the green is taking up a lot more. So we know that the green is more than the pink. And I feel like that's just a quick, easy way to organize their work and like know that they have a good, correct answer because the colors are like completely different. And it also makes it fun for them because like I love to color. So like if I can add coloring with like into my math, I feel like it just makes things easier and you remember things more in color and when you do something fun. And the technology that I said that can be used for this is Google Docs, as we mentioned, or like Word, or the interactive whiteboard that the teachers use.
Yeah, I like colors too and stuff, and like I really like color coordinating. So, oh, is that a dog?
Yeah, that's a dog.
Yeah.
Sorry.
Good interruption. We'll go just kidding. Let's see. Yeah, I like color coordination, and I feel like when teachers had like different color folders for subjects, I was able to organize my work a lot better. So it's really important.
Yes.
Who's next?
I can go next.
Okay.
I did thinking aloud, so that was pretty much where kids talk out about like what they're struggling with or try to explain their situation or what their problem is to get to a solution. So it requires talking through the details, decisions, their reasoning, and then it helps for kids who are struggling because it slows down the process and lets them actually think about what they're doing instead of just trying to rush to do what they're working on and complete it just because their classmates are finished. So it really helps individualize the learning so that they're, as an individual, are learning instead of just as a mass. Let's see, I think that like a lot of like group work is good with this one because it helps them discuss and learn from their peers. So I learn better from my peers. Like I've never really learned from my teachers directly. So having like my peers there to discuss every topic was really beneficial. And so I think that's why in a math class it's a lot better. And then this will also allow them to use a lot of different examples and models by like speaking while they're doing it so that they can show a visual representation because that's a big deal too. Kind of like last week how I was doing presentations, this goes along with that one by talking through it. And then this one also uses the interactive whiteboard was a big one that they used, and manipulatives as well. And then like another way I thought was interesting with this was to give the feedback. You can watch for the students who explain the steps without explaining their decisions, because that can be a big learning curve too, with not understanding how they're getting to the place. And then by speaking aloud, you can understand if they have that appropriate reasoning. Yeah, that's what I got for that.
That's good.
Okay, I'll go next.
Okay.
To define that, so I had math language. So as we all know, math language is like kind of universal, actually. Like, you know, it doesn't really change where you go. Like adding is still adding, and so it's like using precise language. It builds a shared understanding of terms and symbols that all the kids can use to communicate with each other. And I read that it can also, if a shared, like it can eliminate language barriers, because the math terms, like I said, are universal. So even kids who struggle, who are learning English, still can still understand, like, you know, understand it better, because it's everyone speaking the same language essentially in the room. It's like math language. Let's see. Let's see. Yeah, it builds math language builds capacity to learn new things. It supports them in thinking more carefully about their ideas and even their classmates' ideas. It also enables them to clearly communicate and also ask questions. So, like, how can you ask a math question if you don't know how to ask it? You know, stuff like that. I talked about the lesson I found on it was a lesson involving how to define geometry terms. So, like, you know, she was only using a few ones like points, lines, and angles. So what she wanted to do was she wanted students to develop definitions of geometry terms, new vocab and symbols, and then develop a common math language among the students with the geometry terms. So what she does is she writes, like, she draws a picture of what the symbol is, and then she asks them to define it. So she's like, here's a line. I would like you all to write your own definition of what you think a line is. And then same thing with a ray, and then a point. And then students would write them down, and then she would ask for feedback, and then she would kind of correct or like fix things that like weren't quite, you know, right but close. And then they would all write it down on they used Quizlet. So like we all know Quizlet. So she used Quizlet, where like they all wrote their own little flashcards of all the terms, and then so they wrote them on the thing, and then they had them also they had a math vocab journal, like a physical journal that they all wrote it in, that they can study and look back on, and then they all kind of have discussions about why a line is infinite and why a ray starts here, and then she compares it to like real world scenarios, like in our classroom, where would a point be, or someone like a ray being someone stopped here and then going infinitely that way and never stopping, or something like that. Just like comparing it to like real world stuff really helps them. She kind of used an interactive whiteboard, because she had the whiteboard where she would draw what she wanted them to define, and then they would write it and stuff. So, like I said, math language is important. Like, you can't do math if you don't have the language to do it. So, super important, and really important to teach in your lesson plans as well. Okay, and last but not least.
Okay. So my reading was on understanding problems, and it talks a lot about like what we can do as like teachers to help students in the process of like all the problems, and like when we explain something, to make sure we give clear instructions on what we want out of the students, and like what is being asked of the problem, and to make sure that they have a solid understanding of what's being asked. And it also talked about how teachers can do this by like asking their students to like reword the question to make sure they fully understand what it is that is being asked before they go and try and do something. And it also talked about how teachers would have their students like share strategies with other peers on like how they went about solving problems, because there's not like just one way to solve a problem, and you can get to the same answer doing a different variety of things or using like different tools. Like it talked about one person using like the smart boards to like do their math problems, whereas like another person drew out their diagrams and whatever, and just to see like how that can like either be a useful source for one person and maybe something else is better for another person. It also talked about how the importance of like annotations, and usually we think about that like with like reading or like English classes, and we don't really think that, oh, how do annotations help us in math classes? But it was talking about like how after like the first time a student reads like a word problem or something, they may not understand it, but once they read it again after having annotated, they can really pick apart what it's asking and what the important things are, like what the keywords are, and like what other details aren't really relevant to what they're trying to find, and which again can help to determine whether they really understand what is being asked of them and what isn't. And then the last kind of thing is it talked about that like making mistakes, that that it helps like for students to learn and grow from those. And like a lot of like people or like some students may feel like, oh well, I don't want to like share this out because this may be wrong and I don't want to make a mistake, but it can actually help the whole class as well as the individual to learn what it is they do truly understand and what it is they don't, and how they can go about solving this and getting to the right problem by looking at what their process was, and to see how they can like help fix that and eventually get to the correct or like the end goal and have a good idea of what it is that they were doing in the class.
Yeah. Because like as anyone like during class like math, or like someone asked a question that you like wanted to ask but you like didn't want to look stupid, I guess, but like someone asked and you're like
it's like every class for me, not just math class.
Yeah, I mean, I think it's really important just to like hear again, like what other people like the questions and things like that. Just because it also does help, like if you've had that question, or maybe it was something you didn't think about, and you're like, oh yeah, like how does that work, or how does that happen, or whatever it is. Like, I think that's beneficial.
I think we all shared really good points, and we all shared our individual things, and we all covered everything. So yeah, I think we're good. Yeah, yeah. So yeah, I guess we'll discussion next week. So just hit stop broadcast, Maya.
Okay.
And then it should go to the YouTube thing. I don't know. Yeah.
Okay.
And then, copy and then make sure to put on the document.
Okay.
Like where? Yeah. Anyway.
Bye.
Yeah. Bye.
Yeah.